Hello everyone. Myself Vigil Venugopal from Jindal Global Business School. I'm doing this research paper as part of my big data analysis intern project. The topic of my research paper is use of data analytics to identify the pattern of air pollution in Delhi to devise possible strategies for reduction of health impact on residents. Now, the reason why this topic was chosen is if you would see 92% of the world's population actually air quality inhales air of quality which actually exceeds what WHO prescribes, or even if you would take the numbers into 6.5 million deaths are due to indoor and outdoor air pollution. Now, why is this happening? Why are everyone choking? So, when we would actually go into the stats, you would see there are a lot of pollutants such as the particulate matter, sulfur dioxide, carbon monoxide, nitrogen oxide, which are the reason for why this is happening. And if you would see, go into the depth, you would find out the particulate matter is what is most importantly creating the nuances for people in terms of health hazards. We would be we would have heard a lot about Delhi being cursed as the most polluted city, but Delhi still is not, which means that even after going beyond the prescribed limits of WHO for so long, still we are yet to reach the mark of being the most polluted city. So we would actually going through the report, we've actually added the reason why the pollution has been increasing in the Asian countries as we have been moving from the emerging market to a developing market. As India moved into a developing market, the people started having uh, better standards of living. You would actually see a exponential growth in number of cars being bought by the people. I mean, from 1971 to 2000, based on a study done by Badami in 2005, you would see the numbers being tripling or even like going exponentially high. When you would see two-wheelers, the numbers have gone up for 67 times. And if you would see the quality of gasoline which have been used in 1993 compared to what we are using now, you would see sulfur, benzene, all these things are like kind of extinct from what we use. The lead is not even there. But there are a lot of new pollutants which started to come in. I mean, when we started moving into the technological era and as we started to find out um, alternative methods, we started seeing a lot of new particulate matter in whatever we are using, such as sulfur dioxide and nitrogen oxide. And we can always here see the quality standards which are given by the National Ambient Air Quality Standards, which is how much it is to be in each 24 hours gap so that people can exhale it in a healthy condition. And still, we are far, far, far more than what is it is supposed to be in Delhi. So if you would see the sources, you could see vehicular, industrial, and domestic ones. This is how the pollution has been categorized, and the vehicular one being the highest, and we know why. And so now we would actually move into how big data as a educational as through information, how can we actually make a difference in this particular problem? We know this is a social problem and we need to address to it. So there was an activity conducted by IBM in Louisville in Canada. It is named as Project Air Louisville. So what they did over here is they collected the details of people who were actually um, pro-asthmatic and having respiratory diseases, and these are people who used to use inhalers. So what they did is, towards the end of the inhaler, they started to attach a particular sensor. Now, what's the use of the sensor? The sensors were actually used to identify when and where are these inhalers used. With this data, they actually mapped out how this particular in the entire city of Louisville, when and where are the people using the inhalers. This actually helped in, if you would see the stats, an average of 82% reduction in asthma rescue inhaler use. So people stopped using it because right now they collected the data. They know where which areas are prone to actually uh, people who are asthmatic, so that people are advised not to go through that area. This actually helps them in identifying what is to be done. So this is the power of data. Like with the help of data, we are actually identifying how we can reduce the health impacts, even though like we cannot completely eradicate the same. So 29% of the uncontrolled participants gain control over their asthma. So people used to use their asthmatic inhalers very frequently, but once we mapped out the data and we understood that this is an area which I'm not supposed to be traveling to, this actually reduced the use of the inhalers. So on an average, the participants double their symptom-free days. Like they got rid of their symptoms. They knew if I go through route A, I'll be actually being prone to the asthma rather than route B. So they're actually helping them more. So through this research report, these are the objectives that I'm trying to cater to. The primary objective is to identify the pollution levels at various points in Delhi, though we cannot cover all the areas. We are trying to cover the important parts. Identify the social media network and analyze the campaigns related to the pollution debates in Delhi. So over here, what we are trying to do is we had a lot of debates on the topics of odd even campaign or even the Delhi smoke when people are going, the Twitterati is going berserk when something or the other happens. So we are trying to cater to that problem. Our scope is to identify a particular data point with the help of the data given through Central Public Control Board and also the other websites and also other research paper which I've quoted in the paper. We are using Gephi and other tools to find out how to visualize this particular data and to analyze the patterns underlying. So we have used some the shortcoming is we couldn't take everything into account. So if you would see the data analysis have actually taken mapped out the areas into residential and industrial areas. And in the residential areas, you could see the data has been collected till 2015 because the 2016 data is not completely available in the website of NPCP yet. Um, so in the data.gov.in website, the data of 2014 and 2015 is given, when which we are identifying the residential areas and how much we had actually checked. I mean, how much is the mean value of each of this particular matter of particulate matter 2.5 micron, 10 micron, or even nitrogen oxide, or even sulfur dioxide. So through this data, like you could easily see that um, even though there are certain areas which are in residential areas, but actually having the air quality index almost similar to the areas in the industrial areas. So this clearly states that some areas are not easy for people to live in because their air quality index are actually drastically going down, and people are breathing hazardous things all the time. So, in the report, I actually tried to map out all the variables and their type, which are the pollutants which are actually creating the havoc for the people. And then, if you would see, the prescribed limit is 300 in case of particulate matter to 300 micron per area. Uh, in case of particulate matter 2.5, and everything is well within limit. But when it comes to the nitrogen oxides of nitrogen, you would see actually we are going beyond the prescribed limit in the town hall and residential area, as well as um, in Mayapuri, which is actually an industrial area. So you would see a residential area is actually surpassing the limits which are already there in the industrial area. So this actually clears properly to every resident that this particular area is not good to travel around. Sorry, in this particular area would help you to understand that why a particular disease is happening more or cost more in one side rather than the other side. So we'd go back to the data analysis which we have done. We had actually created two tools. So we created the graph files and then we actually did an analysis in Netlytics itself where got the data from. So one was created for the odd even campaign happened in Twitter, while the other one was done for the Delhi smoke which happened. So if you would see the analytics which we have done, so this actually showcases the file for the Delhi smoke. So over here you would see the only node which the maximum number of centrality, that is 31, is actually with the node of Mr. Arvind Kejriwal. So it is very obvious that a political figure will be having the highest in degree and highest eigenvector when a social issue is happening. So people tend to tweet more, retweet more, or mention this particular personality more because they think that if this person is let known about the issue, they'll be getting a higher response. So if you would see the cluster wise, The first cluster is just the clusters hovering around the Chief Minister of Delhi. Um, and then, if you would see the other clusters, and also the density and centralization is very low in this particular model. If you would see other clusters, you would also see the media houses actually having APN Live in the. So you would see the media houses and Indian Express, for example, are also having a huge role to play in such an event. Now, if you would see the second graph created for the odd even campaign, it rather looks very spread out. I mean, there is not much of connection which is happening amongst the members in, or the nodes or the actors in the particular network. This shows that the people were maybe the initial thing, initial boom they had, initial positive sentiments were not actually like capitalized as people lost their interest in this particular activity, and this clearly shows there were a lot of individuals who wanted to talk about this particular issue. If you would see the clusters as well, you would not see much of the eigenvectors. Like all these tweets have been coming from this particular user or actor, but even the CM also has not created much impact in this particular thing. So if you have to give an answer on what happened or about the success of this particular campaign, um, the odd event could not actually reach out to maximum people than people who talked about the smog, which means the problems were more and the solutions were not even interesting to the people or these people residing in the state. So what we could look into as some sort of recommendations, I've just jotted on the points over here. The details have been mentioned in the report. We could actually, with the help of data, we could actually map out the biogas plants, the requirements of biogas plants to be created for crop crops in the neighboring states, so that the burning of the crops and everything is put under control, and so that it doesn't create much of which would not accumulate and add on to what Delhi is already suffering from. And one basic and evergreen idea is to plant more trees, because if you would see the tree cover which we already have, it is not evenly distributed. So if you would take a look into what we have actually found, the tree cover in central Delhi is 20%, while in East Delhi it is only 5%, and same goes with West Delhi. So around out of the nine clusters which we have actually divided into, almost six of them are under 10%. So this is something which we should be giving most importance to, create plant more trees and go more green. And ITS supported by social network. So ITS is nothing but we mentioned in the report. So ITS is intelligent transport system. So since we are more used to what we call as the social networks, and all our smartphones, everyone is moving around with smartphone, and smartphones are the companies are trying to find out the new varieties or new systems which are embedded into it. So why don't we try to figure out a system wherein which people can use their smartphones to sense or to find out the pollutions in and around, and use it as a means to help out others to reduce the exposure to the same. So if you see the model over here, they want a traffic sensor. This could be done with the help of mobile networks, GPS and video cameras, which would transfer onto the environmental sensors, which could be the weather, accident or the pollution. And the final one is the social network sensors, where in which people could talk about it in Twitter, Weibo, Facebook, etc. And post this, we could also try developing recommended truck routes. So we know that vehicular pollution is on evertime high, so it will be the highest from the engines which are having maximum combustion during the highest temperature, causing the particular matter to come in. So you could try out for a better route across a city or around the city rather than going through the city. So these are certain recommendations which we could follow to bring out some changes with the help of data analysis. Uh, it's actually never an easy task to give a clear-cut idea and clear-cut solution to the problem which is upfront, but trying to map out everything, trying to bring everyone on board, trying to analyze the pattern would always give us an idea on how to curb these illnesses which are actually very, very severe to every human being. So we could try to find out a way out only if we are actually creating an intellectual system which includes everyone. So an inclusive intellectual system, thereby coming out with more ideas where we could find out a solution for everything. So that's all from it. Thanks all for watching.